Hello all, let's start another video on section 7.3. In this video, as you see, I will try to cover, to find or to estimate the population mean, but this time we don't know anything about the standard deviation. Most of the time, it's actually a real case. Because most of the time it's so difficult to know about the population standard deviation because we only know the population standard deviation if we know about the mean. But here we are trying to find the mean, how it's possible to know the standard deviation. It's kind of more real case. In previous lecture we found or we estimate the population mean, but a sigma or a standard deviation was known. Here, we don't know anything about sigma. You know, if you don't know standard deviation, which the standard deviation for a population, the symbol is sigma. If I don't know sigma, then I cannot use z-score. The only time that I can use a z-score is if I know sigma or a standard deviation. What to do in this section, what we are doing, we actually use another score which we name it t-score. Instead of z-score, we are using t-score. It's new for you. T-score is also a table, like when you see to the left side of my screen, you see the t-score table. It's table A3 in your book. You have it in your book, and we can use that table instead of z-score. Now, some requirements are what you need. I call it always what you need. You can call it requirements. The first requirement is your sample should be random. You need a random sample as usual. Always your sample should be random. Number two, requirement number two is the sample size should be greater than 30, or it should be or you should have a sample is from population normally distributed. That is normally distributed, correct? Look, before our formula for z-score was z equals x bar minus mu over, because we knew the standard deviation, we had sigma over square root of n. What we do here, instead of z, we use t, correct? We use t-score. It should be lowercase t. I put there uppercase t. It's always lowercase t. T equals x bar minus mu. I cannot use sigma because sigma is not given. Standard deviation is not given, but it's easy to use the standard deviation for a sample, which our notation is s for that, correct? S over what? Square root of n. We are using in this section t-score, and that's the formula for t-score. Now, some more notes. You need critical values. Let's talk about our critical values. Critical values are given by T alpha over 2. Before we had Z alpha over 2, now T alpha over 2. Correct? One thing that we have new here, we call it degrees of freedom, correct? I will talk what is a degree of freedom, or what is degrees of freedom, correct? And I'll explain what does it mean actually. Degrees of freedom. The degrees of freedom, which we denote as a df, I think we denote as a lowercase df or uppercase df. df equals your sample size minus 1. It gives you always the degrees of freedom. What does it mean? Let me explain for you. For example, if I pick 10 numbers, correct? If I pick 10 numbers, let me draw here 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And I will tell you that these 10 numbers should have an average of 100. Pick up 10 numbers to get an average, correct? To get an average of 10 and 100, correct? Is it possible or not? Some of you may say no, some of you may say yes. For example, the easy sample is like 10 numbers to give you 100 of an average of 100. All of them can be 100, right? 100, 100, 100, all 10. The average will become 100. Correct? There are different ways. Even, let's say, I'll put 9 different numbers. For example, here -3, here 5, here 13, correct? Here, let's say, -110, here 15, here 25, here -50, correct? Here, let's say 47, let's say here 364. I'll put 9 numbers, but I'll keep one number, which I call this number set stone, correct? Still, I can make the average of this 10 number 100 if I have this freedom, this set stone. Based on this number, I can change my average to 100. Hopefully, this explanation will give you an idea what is degrees of freedom. Degrees of freedom means like this, that you always have a set stone, a number that can change everything, correct? I call it set stone. In your book, maybe they call it something else. Actually, even they didn't explain what is a degree of freedom very well there. But this is the idea behind of the degree of freedom, that you can change anything. For example, here in this example, the average to 100, even these 9 numbers doesn't give you an average of 100, but one number, this number, can change everything. Correct? That's the idea of behind the degrees of freedom. Correct? Let's do an example, and later I will show you how to use your t-table, correct? Let's do an example to explain everything. In this example, a sample of 23 from a normally distributed population, a sample of 23 from a normally distributed population. Find the critical value find the critical value T alpha over 2. Find the critical value of T alpha over 2 for a confidence level of 95%. Now, few things. How much is my n? A sample of 23. Okay. The sample is less than 30. Can I solve this problem? We have to read carefully this problem. If my sample was 31, 35, 40, 45, yes, no problem, I can solve this. But now my sample size is less than 30. Can I still solve this problem? The only part that enables me to solve this problem is these two words. Population normally distributed. If you don't have these two words in your problem and you are dealing with the sample size less than 30, less than 31, or your sample size is even 30, you cannot solve that problem. Correct? But right now we can, because it's normally, our population is normally distributed. Our confidence level is 95%, correct? Which means for us 0.95, correct? Can I easily find alpha? How much is alpha? If this is 0.95, then my alpha will be 0.05, correct? 1 minus this, which gives me 0.05, correct? And our T alpha over 2, we will find soon, correct? Next thing that you have to deal is degree of freedom, up, degree of freedom, DF, degrees of freedom. The formula is n minus 1. Then your degree of freedom will be 23 minus 1, which gives you what? 22. Correct? Now, we are using our table A3 to find what? T alpha over 2. Correct? Let's go back to the table. I'll try to zoom in for you. Let's start with the top. Table A3, T distribution, critical T values. As you see again, that your critical values will give you the area to the left. If you look here on the side, your critical value gives you the area to the left always. You see the left side is shaded. Now, in the top row, please mark your table like me, because in your book, it's not marked. The bottom is alpha. These values are alpha. This is alpha. All of them. This line shows your alpha. Correct? The top one is alpha over 2. It doesn't matter in these problems that if you use alpha over 2 or just alpha, because you see the actual table, the values are the same in each column for both of them. Now, for this particular problem, you see your Z alpha is, your alpha is 0.05, correct? Go to 0.05 and your degrees of freedom, which is in the first column, all these numbers shows the degrees of freedom. Your degree of freedom is 22. Correct? Now, come down this way, like you did for Z-score, and go this way. And you will see you end up with 2.074. Correct? Your T alpha over 2 easily from the table you can find is 2.07. Correct? This is how you calculate your T score, table A3 in your book. Correct? It was a simple example. We will do more. But before that, let's talk a little bit about margin of error. We have to find margin of error. Correct? The formula for the margin, again, the symbol will be E for you. The formula for the margin of error, instead of Z alpha over 2, this time we are using T alpha over 2. Times before you had here sigma, right now we are using the sample standard deviation, which will be given for you in the example, correct? And square root of n. This is the formula that you calculate or the margin of error. How to build confidence interval? Because now you know you can find your critical value, you learn, you can find the margin of error, and if you can do this, then you can build a confidence interval, correct? Let's talk about confidence interval. How to build the confidence interval? What we are calculating, what we are after the finding the population mean or estimating the population mean, correct? To build the confidence interval, because our target is to estimate the population mean, we use mu in the center. Of course, our point estimate for the mean, estimating the mean of population, our point estimate will be x bar, sample mean, correct? Plus margin of error. And on this side, x bar minus margin of error. It's really important for you to understand how you build a confidence interval. If your target or if your goal is to estimate a population mean, put the population mean, point estimate for the population mean will be the sample population, the sample mean. If you want to estimate, for example, which is the next section, the population standard deviation, which is sigma, correct? If you put sigma in the middle, then the point estimate for sigma is S, the sample standard deviation, correct? Whatever your goal is, you put that one in the middle, and on two sides you use your point estimate and margin of error, correct? Now, let's do an example. Let's build a confidence interval, a good example. Construct a 95% confidence interval for the average age of people for the average age of people denied a promotion. I didn't put the full example here for you, but I'll explain what was the case, correct? Denied a promotion in a random sample of 23 people, in a random sample of 23 people, the average age was 47.0 years. With a standard deviation of 7.2 years. Okay. In a company, employees were denied promotion if they were an age 47 and above. The company was not willing to give promotion to these employees. They were usually targeting younger employees. It's happening a lot. Someone built this case, those employees complained, and they built a case. Now we want to give them actually a document to support their case, correct? I'll put one more wording at the end of this problem. Assume this sample comes from a population normally distributed. That is normally distributed. If I don't have this last sentence in the problem, even I could not solve this problem because my sample size is only 23. It's less than 30. But normally distributed again gives me the power to solve this problem. Let's start from the beginning. How much is n? Your sample size is 23. Correct? Then degree. I'm always writing capital, trying to control myself. Degree of freedom will be n minus 1, which is 23 minus 1, which gives you 22. Correct? The mean of the sample is given to you. The average age was 47. Correct? And standard deviation is given for the sample for you, which is 7.2. Correct? Confidence interval, they told us 95. Correct? My confidence level is 0.95, then my alpha will be 0.05. Correct? Now, the first step is to find T alpha over 2, which is your table. Basically, in this example, I used the same value that before we used, and we know our T alpha over 2. If you look here, sample size is 22, and your T alpha is 0.05, correct? Then it's 2.074. It's again T alpha over 2 is 2.074. Now I know all of these. I will work on the margin of error. E equals T alpha over 2 times S over a square root of n. And if you plug in the values, it will be 2.074 times S, which is 7.2, over square root of 23. Using calculator, your step 1 is multiply these two numbers. Correct? And also divide take the square root of 23 and then divide. And if you do this process, let me take out my calculator and multiply it for you to show step by step. If I multiply the two top numbers on the top, I have 2.074 times 7.2, right? 7.2. Enter. It gives me 14. Please do not round off. 14.93 to 8. Divide by square root of 23. Let's take the square root of 23. 4.79583153. Correct? And if you do this division, your E will be equals to, let's say how much? 3.11. Correct? Which we calculate as a 3.1. Margin of error. Correct? Now I will build my confidence interval, which they asked me to build the confidence interval. Correct? Confidence interval will be mu on this side, x bar plus E, this side x bar minus E. Then mu less than x bar, which is 47.0, plus E 3.1, on this side 47.0 minus 3.1. Mu will be between 50.1 and greater than 43.9. Correct? What explains here, actually you see 47 is between in these two numbers. Correct? This gives a full support to the case that yes, the company is actually avoiding give promotion to people that they are 47 years old or older. Correct? Last part of the lecture after this example, I can write for you. If you know your confidence interval, if you have your confidence interval, which is mu less than x bar plus E and greater than x bar minus E, correct? You can find x bar and also you can find E. I explained before in the previous lecture how to find x bar and E. It's actually the same way. If you want to find your x bar equals upper, which is this side, plus lower, and you know the reason because I already explained, divide by what? Divide by 2. And for E equals upper minus lower, divide by 2. Two formulas if you want to find the value of E. Correct? This was all about last part of 7.3. I'll stop the lecture and see you all in 7.4, which we will discuss the chi-score, another table, how to use chi-score, when we use chi-score, when we are trying to estimate the population, standard deviation, and variance. Correct? See you all in 7.4.